My dear students, moderators, coordinators, and the dynamic Professor Raja. Nice to have you on the third day once again. Thank you so much for giving me this opportunity again and again. And for the students to know, you would have seen this Milan now in the screen. I really don't know whether you know about this or heard about this or not. This is an annual festival which we have in SRMIST campus, Katangulutur, every year. And there's a lot of students across the country will come and join and have the great celebrations. People come in lakhs together, and a lot of celebrities, international celebrities, national celebrities, local celebrities, everybody will join and felicitate the program. And that's going to be a very great session. Like that, we also have something called Arush, and many other events happens. Once you come to the campus, and that's it, you'll be more flattened. Such a way of campus we have. And for others, we like to tell you what means SRM. SRM means Ramasamy Memorial, Sri Ramasamy Memorial. So it is called Sri Ramasamy Memorial Institute of Technology. So SRMIST. That's what it is for many people who don't know. Also, it has been headed and led by Dr. Sandeep Sanchetti, Vice Chancellor of SRMIST, and he is heading 4 campuses. One is SRMIST Katangulutur, and one more at Ramapuram campus, Chennai, one more at Vadabalani campus, Chennai, and one more at Modi Nagar NCR campus, Delhi. So all these things, all these 4 campuses comes under the umbrella of Dr. Sandeep Sanchetti, Vice Chancellor, SRMIST. Of course, apart from that, we also have different universities, different campuses at Amaravati, Trichy, and many other places in the country and out of the country. This is all headed by different experts. So just for your information, apart from that, we also have a campus life, and we have campus directors, and they take care of campus. And there's something called international relations, external affairs, and they take care of the international affairs. So they take you to semester program. You can travel outside the country and do your education for 1 or 2 semesters. And they also take you for international tours. They also take you have MOU, and you have exchange programs. Many things will be done by the IR department. And we also have QAR, quality assurance and ranking. We have a separate department. They take care of the quality controls and something like NARF ranking and all these stuffs. And we also have something called Alumni affairs. This born in 1985, and this architecture is born in 1992 in SRMIST, and probably almost 28 years. And we have a full set of 28 years of alumni, and that alumni department is taken up by other heads. Like that, it keeps going on. In SRMIST campus, with 250 acres, we have a medical college, engineering college, arts and science college, law college, management college, and whatnot, all colleges like other allied services like nursing, physiotherapy, homeopathy, siddha, yoga, all these stuffs, all these things. Along with, we have a school of architecture and design, very dynamically performed. So that's how it is about it. And once you come to campus, you fall in love, and that's the way of living, and that's so cosmo. And you will enjoy the session. It will become a child. We keep playing, enjoying, not only with the campus, but also with the faculty, with the environment, and also especially with the course. The course itself is designed in such a way that that's going to be excellent, amazing. You will live the life for the 5 years, and of course that will continue through the life. That's what it is. Thank you very much for the opportunity given. Let's celebrate today and every day throughout life. All the best. Thank you.
Thank you so much, Dean sir. I would like to once again repeat my request for all the new entrants who have just joined in. Kindly rename yourself with the SRNNT number given by our tutor sir in the WhatsApp group as you had registered, along with your name following it. Kindly do it so that it will be easy for us to call you. And put your videos on. This is a recorded session. We will be observing your participation, and this carries weightage in the evaluation process for us to know how active and interactive you are. Please, I very often see many of the videos are not being put on. Kindly put it in. And for those who have not introduced themselves and given the application number in the WhatsApp group, kindly put it in so that we could record your registration, so that we could also send in the information easily to you, because we will be calling on your applications for the personal interview, and for all the interview calls will be this number. This registration number is going to be the clue list for us to call you in. So kindly, for those who have not introduced themselves and given the number, kindly do so after the session in the WhatsApp group. Now I call upon our dear Professor Raja to rock again.
Thank you. Very good morning, my dear friends, and thank you so much for for your posters, paintings, your photographs you have sent. Almost around till 1 o'clock in the night. It was pinging, and I just wanted to see, because I was so enthusiastic to see the kind of work which you are doing. Nadira, you can put 100 SRNT 100 for you. You are the 100th person, no, Nadira? You put rename it as SRNT 100 Nadira Sultan. How beautiful it will be, huh? 100. You are the 100th person. Thank you. So today's class is a very important class, guys. Today's class, we are actually going to jump from an artistical perspective of looking at our entire program, a small geometrical way, how we actually convey our message. So it's very important how we convey our message. In all our photographs and
Please be online. I think sir sometimes
questions which are involved. Let me share my PowerPoint presentation and we'll have a discussion. Okay. Can you see my PowerPoint presentation? All of you can see?
Sir. Yes.
Yes, that's clear.
So let's celebrate life for another one more day, and you're going to celebrate every day. We saw today the Milan Festival also. I've been to this Milan Festival. It's like rocking performances everywhere. The people are so creative. Always architectural department comes alive. Most of the people actually, they actually appreciate architectural department like anything in the Milan Festival. It's a wonderful festival. I hope you all will be part of next year's Milan Festival. So today we are actually going to talk about a very serious thing. It is a very important thing as far as NATA is also concerned, because NATA is actually trying to understand what is the geometrical value which you have. First, we actually talked about artistical value and expression of artisticness in you, and the creative manipulation which you have. The aesthetic sensitivity is really tested. Today, NATA is asking for how well you can actually relate those beautiful things in the nature to the geometry, because as an architect, you are actually going to reproduce or biomimic the nature through the geometry. So you must have actually a knowledge about geometry. This is all what we have actually studied in our first standard, second standard, and fifth standard. It might look so familiar to you. Now we'll actually talk about three projections. One is oblique projections, an isometric, orthographic projection. Then I'll actually come to a combination of solids, addition, subtraction, and interactions happen. Question number 1, we will actually poll it now. Can I ask you, can we see all the sides of a solid? Yes or no, in real life through your eyes? All of you are great, people, who have actually done lots of work. Can you see all the sides of a solid? So good, all of you woke up now actually. Can you see all the sides of a solid? I think there is some transparent persons here. 12 of them actually have transparent eyes to, they actually see a solid. Maybe they thought like I'm talking about a glass surface, maybe that is the reason why they could see the other side also. It's great. A solid, you cannot see all the sides of a solid unless it is actually a glass, okay? So we'll share the results and we'll go to the class directly. Here we are actually. A line which we talked about, when line is projected, a line is projected. Just imagine this is just a paper which you are having, a white paper which you are having. A line is actually projected, a volume is actually getting created. We already talked about our shapes and we talked about the solids, how well a paper is actually translating as a medium to speak about a volume in a plane, you know, different planes. Like, you know, say for an example, if you have an axis, you have an X and Y axis, you have Z axis, but Z axis cannot be seen. That is not in the paper, but you actually visualize Z axis which is coming into your eyes. This is what we actually visualize through the paper. When a line is projected, a volume is created. As you can see, the dotted lines which I have put are the volume, the plane in which the volume is actually created. Now, in normal circumstances, see, I'm taking this in a very easy way for you to understand and answer your NATA questions clearly. You know, be very cautious, you know, be attentive and try to understand everything so that it is easy for you. There are lots of questions which are asked in this subject. Okay, so this all those aptitude questions and geometrical questions are asked from this subject. So kindly be attentive and try to understand. If you don't understand anything, you just ping me. This is a top plane which we call, this is the bottom plane which we call, this is a side plane, this is a side plane which we have. These are four things. When it is actually projected in an angle, we get this kind of planes, you know, like you can see a room here which has got top, bottom, side planes. A base projections in architecture, a 2D plane is actually getting converted into a 3D plane with original surfaces. Please understand, when a dimension is given, it actually replicates the originality of the entire fabric. So 2D is actually becoming a 3D as a cube. You can see in some of the surfaces, you cannot see some of the surfaces. The 3D plane with original surfaces. But in architecture, we try to see these projections through different mediums of understanding. They are called as, one is a perspective projection, second is isometric projection, third is an oblique projection. There are two important things. The perspective and isometric projection are original projections. An oblique projection is an understanding of these planes. We will actually go and try to understand. Question number 3. How many surfaces are there in a cube? I request all of you to answer. There is a poll which is there on top of your screen. So click the poll. It's very important question which we are asking now. So all of you poll. Yes, almost all of you are polled. So thank you. I think most of them have actually come up with the right answer. That is 6 actually. The surfaces are very, very important. It is a very, very important lesson to be learned for an architect. For an architect, it's a very important. I have actually talked about an artist and an architect. You know, an artist is a person actually creates some imaginary thing, but an architect is a person who creates imaginary thing. At the same time, he creates it on originality. That means that thing will be there in original, in real. That is the most important factor. When you actually do everything in real, you have to have all the dimensions intact. The artist actually sometimes actually hides so many things. He uses shading and all the devices and try to hide what is there in the behind. If suppose for an example, a girl's portrait is actually designed, a girl is actually not having a hair in the back, still he can actually create a beautiful, I mean, everyone is a beautiful one, but he can actually make it look like she has lots of of hair. So that is the falsifying thing which an artist can do, but an architect cannot do it. I cannot make my three faces so beautiful and one face ugly. So you have to know the surfaces very well. All the surfaces has to be understood. So this is the idea. That is the reason why we are learning this. This is a cube, okay? There is a small cube. Please attentive. There is a cube which we are actually seeing. There are 4 squares in the cube. This is all we know. There are 4 squares in the cube. This is called a surface development. In NATA examination, they will be asking surface development. Specifically, they will be asking surface development. The 1, 2, 3 cube, say for an example, if I actually hide the view, top view, can I actually take this top view and put it in number 5? Can I actually take the bottom view and put it in number 4? Yes, everyone is actually looking the same. So whenever you actually see a cube or anything like that, go home, practice with the cube and try to identify everything through a number or ABCD, alphabets. You try to actually name them. Every surface has to be named. When it comes to a cube, there are 6 faces. The 6, I've written wrongly, it's 5. There are 6 faces. The 6 faces has to be actually absolutely correct. The 6 faces has to give a different variety. When you actually use a light, what will happen? The number 1 top view will actually be bright. Number 2 bottom will be absolutely dark. Number 3 front view actually will have a medium kind of density towards the shading. 4th view will actually have a brightness. Side views may actually have a darkness in it. So you please be very clear whenever you are actually drawing a beautiful surface or any kind of a solid, try to name it. In architectural terms, it is called as plan, bottom plan, front elevations, rear elevation, and side elevations. You know, this is the way it is actually called from 1, 2, 3, 4, 5, and 6. In my architectural classes, usually what I do, I request my kids to actually make this kind of a cross, a Latin cross kind of a thing, which I really ask them to make. There's a 1, 2, 3, 4, 5, 6 squares together in a cardboard or in a sheet, actually a thick sheet. I ask them to actually make. No, you actually make them, you know, in your house, you actually make it with a small little paper. Surface development of a cube can be actually done like that. See, this is actually done by one of my architectural aspirant, a student of mine. She had done this beautiful thing. She cut it, she used a cutter, and she got this beautiful thing. After getting this, folding and unfolding of solids creates possibility of many creations. So once you actually start learning this through a medium, see, model making is a very important thing as far as architecture is concerned. Model making actually gives you all the surfaces. You can see all the surfaces. You are talking about only 2 surfaces now through art, but in surfaces, all the surfaces to understand, you have to actually understand in this way only. So you have to actually go make this kind of a surface development, try to understand. This is what has been done by our students. The cube, what is this? What is this? What is this? You have to actually tell me, you actually make all these things and put it in your Google NATA group, and you know how well you can actually understand everything. It is not only all these 4, you can create as many as you want and try to understand how many surfaces are there. I tell you, my dear students, do it. You'll get 5 marks. You'll get 5 marks in that 75 marks. Absolutely, I tell you seriously. The first aptitude is cleared by you. Do it, and you'll be cleared. You don't need to actually do your questions and answers. You do this and you'll be actually on. This is the question which is asked in NATA. Which one of the answer figures shows the correct view of the problem figure after the problem figure is opened up? So they have given a problem figure here and they actually opened it up. Okay. Now, what you usually students do, again, immediately they will do is like, okay, inky, pinky, ponky, father has a donkey, like that. They try. Some people actually might, okay, 1, 2, 3, 4, 5. It's like, they actually imaginatively do this. Don't do it. As I told you, you mark the surfaces 1, 2, 3, 4, 5. Okay, try to visualize the other side also. You've already done this folding paper, then you can easily answer this question. In a second, you will answer this question. So try to do it. Take your own time answering the questions. Okay. Then another development which is given here, the development of a lateral surfaces of a pentagonal pyramid is, so they are asking lateral surfaces. So they are talking about a surface development. So you have to actually answer them. They have clearly given you a beautiful picture. You can easily say how many rectangles, how many squares, how many triangles, how many circles are there. You can answer it very clearly and easily. So you can always see this. You try to actually develop that pentagonal pyramids or any form which you want to create. I tell you, now you go home, try to actually make these cubes, color every cube you color it. Tomorrow Aravind sir is going to give you a color theory. After that, you will realize that, what are the colors which you have to actually make it, so that, 1, 2, 3, 4, 5 can actually be repeated. Question number 3. When we see a line projected in a paper, you feel the line in 3 dimensions, yes or no?
Students, the poll is on. You can answer the poll.
I think people are getting confused. My dear friends, I think we need to actually introspect, and we have to see all the lines which we project in the field can actually give you a feel of 3 dimension. There is no doubt about that actually, right? So we will actually go ahead and we'll see how it is done. Oblique projection, the first one, which is called as oblique projection. As you can see, whenever you draw, take an x-axis, you can see the arrow here. This is the x-axis. There is an arrow which is here, that is y-axis. So this is what you are going to do in your life from today onwards. It is a grid pattern in which you are going to work. You must know what is an x-axis and what is an y-axis. They call it UCS, Universal Coordinate System. So we'll learn about that, but it's simple. Just think that, it is a line. I have made a line here that is called as a picture plane. A picture plane is a defined line, okay? So when it comes to an oblique projection, see, this object is kept like an elevational way. That means it is intact in this way. See, it is like this way only, okay? But in the picture plane, in an oblique projection, they try to project it like this. Okay? This is
Hello, Raja sir. We will have him back. I guess he's having a little bit of bandwidth issues. So, what you
projection
notice,
where there is no angle. This. Yeah.
Yes.
Next is, in oblique projection. What is oblique projections? Okay. In oblique drawings, one set of planes of the object is always presented in it. That means one face will be there in true shape. That means there is only one face which will be actually true shape. From those true shapes, there are parallel lines connected to, parallel lines can be drawn at an angle, any angle, 45 degrees, angle to represent the perpendicular to them. So you have to understand this clearly. You have आपको समझना भी चाहिए. That's very, very important. You try to understand, try to learn. எல்லாத்தையும் நீங்க புரிஞ்சுக்கணும். These lines which represent the perpendiculars to the true shape planes are called as receding lines. Now I have given you a last line where they were receding lines. Those receding lines are imaginary lines. I am just comparing an isometric with the oblique. So that is the reason why I am telling this. Do not actually put that in a very deeper sense. This is what actually you have to understand. All planes parallel to the picture plane are true shape areas. and are all drawn at the same scale on the drawing. That means now you are actually keeping a picture plane. The front one which is there in the picture plane is the true shape. You know, the front one which is there in the picture plane is the true shape. The residing line which is being taken are not true. It is actually an imaginary one. See it, that doesn't have a dimension, correct dimension. It may actually in a vertical perpendicular way. So that is what you have to understand from an oblique connection. From those true shape areas, parallel lines can be drawn at an angle to represent perpendicular to them. These lines which represent the perpendicular to the true shape planes are called as they are actually changing the true value of the system which is already there. Second is a very important thing, that is isometric projections. You know, isometric projections, my dear friends, are true. They are actually giving you a dimension. All the architectural work in the world, when it comes to detailing, you all know about perspective and painting, but when it comes to detailing, people actually go for isometric drawing, because isometric gives you a dimension, true dimension of the entire object. Here in this picture, which I have drawn in a slate, if you can see, there is a picture plane here. There is an angle of z-axis which is being taken. There is an angle of z-axis. This is an x-axis. This is the z-axis which is actually proceeding. The receding line you see, receding line which you saw it in when saw it in oblique projection is an imaginary line. But here, this is a true dimension at an angle of 30 degrees. This length, which is actually given here, is the original form of that square. That square is the cube is actually tilted, and it is giving a true dimension here, true dimension here. This is all called as original true receding lines. They'll be asking this. The x-axis and the y-axis is there. And isometric, the object is turned so that all three axis lines are in the same angle. Say it is like that. It is actually changed in an angle of 30 degrees and everything is in the angle with the picture plane. Since the three axis lines are mutually perpendicular, their projections still make equal angles with each other. That means it's all going to make an equal angle and it's going to create a beautiful geometry. The geometry will be perfect geometry. That means the geometry will be true geometry with the true dimension in an isometric drawing. When a cube is drawn, all three faces will be exactly the same size and shape whatever the directions of the axis line. So all will be actually of the exact same line. We'll go to the picture and see it is all the same here. You know, all the dimensions are actually same here, and we shape whatever directions of the side. Regardless of the directions of the axis, the three visible faces of the object are always turned at the same angle to the picture plane. So it is all turned at the same angle to the picture plane. You can see the faces here. The faces which we talked about, the 6 faces which we talked about. Isometric drawings gives only one picture. No variation of the picture is possible. No variation of the picture is possible. In a perspective, it is different. But in an isometric is a true value of a system, true value of a geometry. It gives only one picture. No variation of a picture can be possible because it actually gives you the true dimension of the cube which we have spoken about. Those squares which were equal, the squares will be equal here also. In an isometric drawing, one axis is vertical and other two are drawing at 30 degrees to the horizontal plane. Please always remember in an isometric drawing, whenever you draw an isometric drawing, in the combination of solids, in NATA questions, they actually ask you to make an isometric drawing. Please remember one thing very clearly. Because in isometric drawing only you'll be going to actually make those combination of solids. So make sure never in all the views, the vertical line will be vertical. In perspective, vertical line will be vertical. Oblique, vertical line will be vertical. In isometric, vertical line will be vertical. No change. perspective in an angle, vertical line also. Can you hear me, ma'am?
Yes, sir.
Yeah, the vertical line is also tilted. Because of the vertical line which is tilted, you might actually get a bad picture. Usually all the students actually make this mistake, though we are very good in, because they are very creative, they actually make lots of paintings and all, they tend to actually make it, you know, it an angular way. So make sure that you don't make it in an angular way. Question number 4, what is a plan? Okay, most of you have actually said that it is the top view. Yes, correct. In architectural term, plan means it is a top view of the building, of anything which we draw. So that is the top view. We'll now talk about the top views, the front views, and side views, because in NATA they ask these questions very frequently. There are so many questions. They want you to understand how well you are relating the 3-dimension to 2-dimension. It's very, very important how you actually relate a 2-dimension to 3-dimension. So it's very important how you actually make it. So we will actually talk about how those projections are actually done here. Isometric projections of identification. If you take, I am actually putting a pictorial here. In this picture, you can actually see there is a top view which has been done here. There's a top view which has been done here. How to identify a top view? But the top view is only this much. Is it true? No. Is it this much? True. I think there are some people who actually make an angle also of it. You know, sometimes when they actually make a top view, try to understand, you actually understand the edges very well. After understanding the edges, there will be only one edge to a vertical line. By doing that, you'll get a perfect top line. So this is the top view, which is called as a plan. From an isometric drawing only, they will be asking all these questions. There is a right view, they'll be asking. There will be a front view, they'll be asking. There will be a left view, they'll be asking. You try to identify the surfaces to the naming of surfaces. 1, 2, 3, 4, 5, 6, 7. So you keep on actually naming them before answering the question in NATA or in SRM question paper. Okay, try to identify the surfaces to the naming of surfaces and imagine and work. I'll actually give you some suggestions and some tips also regarding that. In this picture, you have to draw this picture for your exercise. Just imagine there are lots of things which are happening. There is a small little projection here. There is a small little projection here. There are some holes which are here. There is another projection here. See, whenever you actually, you know, make any drawing of isometric, try to remember only one thing. All are solids. In entire fabric, entire nature, whatever you draw, all actually are from the solid, basic solids. So try to identify. This is what? This is a cuboid. This is a cuboid. This is what? You just try to understand. This is a cuboid. Then you can see there is a cylinder which is actually inside. Today we'll be talking about additions and subtractions also. You actually try to relate this with the prism. Try to relate something with the triangle. So when you actually try to relate all these things with that, imagine in that way, then you will be able to actually relate anything. You can easily draw all these things if you relate them with the basic fundamental or solids and shapes. Isometric projection identification. Say this is the answer for what we have actually drawn here. So identify the edges first. 1, 2, 3, 4, 5, 6, 7, 8. So the edges has to be really understood properly. If you understand this edge, then you can easily actually correspond that edge here. There is a easy correspondence of this edge here. There is a easy correspondence of other edge here. So you keep on actually understanding that in a proper way, you can make everything absolutely fine. So you have to project it and get this identification of the space which you have actually made. So try to make it. Don't actually make any hidden lines, okay? but I've actually made these hidden lines for you to understand what exactly is there in that. Okay, so identify the edges, project it with the lines, imagine the plane. Okay, always imagine the plane. Try to imagine what is a top plane, what is a side plane, and what is the front plane. By doing that, you can easily imagine and draw this. But see, I tell you, most of the people make mistakes in NATA examination and JEE paper 2 also. Whenever they are actually given this this pattern, they are like, very lethargic about this thing. So they make lots of mistakes because see, the examiners also are giving wrong answers. Like they are very calculative with your wrong answers. You are thinking that they are working more for the wrong answers. Whenever I set a question paper, I tell you, I work more for the wrong answer than for the right answer. Okay, so they work so hard, they try to confuse you. So try actually in an MCQ format, always remember, you try to solve that question. When you come out of the examination hall, don't ask, Aparajita, Abhay, Sanju, is it correct? No, you should never ask that question. You should tell to yourself, yes, I am correct. Raja has done the right job. Raja has really actually worked on that program and he has done it. Don't ask question. Fourth question, what was the answer? Fifth question, what was the answer? You know the solutions. Why are you asking the other people? Isometric projections, I'm giving you some practice exercises. This is one practice exercise which is very useful for you because it gives you a same view. So try to actually make this small composition with a plan view and the front view and the side view, and try to work. See, I have given step by step. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it keeps on getting complicated. Okay. So what you do, you work on the entire page, take a photograph, and I'll send you the PDF also. This one, you actually, do it. I tell you, 10 marks extra. So you got 15 marks now. Okay. So NATA, you can actually, at least now you passed NATA examination. You are in SRM college, SRMIST. Okay. Instead you are in. Okay. I'm just telling you how this is done in machine drawing and all. I don't want to actually explain, but you can see the detailing which is done in this machine drawing here, wonderfully done. So the plumber's block is being actually done in a very isometric way. This is an architectural detail which has been done. Again, you can see lots of detailing which has been done, like they have done it a beautiful way. This is how the isometric is actually done. Second is an orthographic projections, how we actually get the plans. See, basically I told you in the isometric itself, but they are called as orthographic projections. They actually have to project. Okay, take a cube and try to actually take this residing. This is the first exercise which you have to do. Just take a cube, take a residing line and mark it A, B, C, D, E, F. Then you actually take a projection and try to actually make that projection on top. Try to make the projection on the side. Take to see, this has been actually done in a different way. Still, I actually want to show you because this is enough for you to understand the basic format. So you project all these things. E is here, A is here, C is here, B is here. By doing this, you'll be able to actually get everything correct. Use parallel lines to project its outline onto a plane. Try to actually use a parallel line to project it outline on the plane. This is one NATA question which they have asked. The 3D problem image which is shown here of a given object. Identify the current front view from among the answers figures looking in the direction. Most of the people, I think, they actually go for this answer because they are all artistical people, very creative. Usually they think in an angular way. They actually keep on thinking and they actually put this answer. So identify the surface by naming them. First surface a name pannunga. Pehle aap jaake surface ko name kariyega. Identify the surface by naming them. Which view is asked? Ask them like they are asking front view. They are saying front view. Anu Pretty, I'll give you a time question and answer. Na? I'll give you because I'm just finishing it off. Once we finish, we'll have a question and answer. Identify surface by naming them first. Which view is asked? Not check that, underline that, which view is asked. Check for that front view. There will be more questions for the SRMIST entrance examination also. You be prepared, all of you 100 people, be prepared for that. Okay, check for the front view. Look at the direction given in the problem sheet. Okay, look at the problem which is given in the problem sheet. Which direction? No, there is a direction which is given. You look at for that and solve the problem. So I come to a conclusion of isometric and projections, which we'll actually discuss about one of the questions. Now I'm actually going to talk about addition, subtraction, intersection of solids. It is a very important thing. See, Raja is there. Okay, why I'm beautiful or I'm handsome? I'm handsome. Okay, no problem. I'm handsome because I have a spear in my head. You know, I have a spear, right? I have a spear, round spear. Then I have, see, there is a small little prism which is there, like my nose thinking. Okay, and I have a rectangular body. See, I have a rectangular body. See, can you see? This is a cylindrical neck I have. I don't know whether it is cylindrical, but take it. Okay, no problem. Just think me as Shah Rukh Khan or something like that. Okay. So like it's a like neck you have, say the beautiful neck which I have, say neck is a cylinder. Okay, even Shah Rukh Khan is having the same neck, but he's having more money in car. I have a small neck. Okay. Addition, subtraction, and intersection of solids. Okay, so a sphere is added to the cylinder. A cylinder is added to a cuboid. Like when these kind of additions happen, they create a magic. That magic. Now you see my eyes. Okay, twang, it's gone. Twang, gone. If suppose for an example, if it is literally a sphere, what will happen? I look ugly. Okay, because there is a subtraction which has actually happened. Some people like Shah Rukh Khan get a ting here. Okay, I don't know what do you call for this? You get a ting here. Okay. That ding gets dimple. Dimple. Okay, sorry, dimple. I know dimple kabaddi. Like okay, dimple. Like somebody was asking me. Dimple is here. Okay, this dimple is actually created out of a subtraction. Like this is also interesting. So this is what actually happened. Question number 5. When two solids come together, they form an interesting solid. Agree or disagree? Very good. Everyone is attentive. Very attentive. Very good. Some 4 or 5 people are not waken up from their this thing, or just sipping a coffee. Sir, wait for sir. So 3-4 people have to actually do it. Let's wait. We'll wait today.
So I'm waiting. It's yes. Only 86%. 8 more people has to do it.
Sir, we are also 4-5 people. Yes, that's SRMIST people, yaar. Come on. All have voted really beautiful. 96% said yes. Two solids come together, they form a beautiful, interesting solid. Yes, this is correct. Because two solids in my head is actually making me a beautiful. Aishwarya Rai is so beautiful, and Deepika Padukone is actually so beautiful because of that. Okay, so it's all those solids which are coming together. Okay, so next, everyone loves it. I also love it. Okay, see, addition and subtraction and intersection. Okay, beautiful cake. Okay, great cake is there actually. A birthday cake which is actually given. Okay, birthday cake is a beautiful form of a solid. Your sister actually or your brother actually takes one piece of it, and what is this? It is a prism which he has taken it out. Yes, he has taken out. So tomorrow you actually go and tell your amma when she actually is making a chapati. Ma, you are making a circle. Okay, good. You are making a circle. Tomorrow you actually eat a pizza and cut a pizza. You tell your friends, hey, I am taking a triangle with me. Okay, it's a beautiful triangle which you are taking. Okay, so when you are eating a cone ice cream, then you tell your people there is an addition happening. You have to just keep on talking to your father and mother like this. You know, see, there is an addition happening. Your mother will be shocked because architects are like that only. So mother will be shocked. What happened to this kid? You know, what happened to Shreya? What happened to Nega? Or what happened to Ashwin? You know, like why he's talking about a spear. And all the times, like you are actually, and after that, whenever you are actually licking that, this ice cream, what will happen? The spear will go away. Only the cone will be there. So you tell the people, like to your friends, see, I had a composition of spear and I had a composition of a cone. Now I have left with only cone. You know, like after that you'll eat that cone also. You'll be left with nothing, or you'll be like, okay, next cone you give me, mom, please give me one more cone so that I can actually experiment on it. Okay. Then mom is actually putting a idli on your idli tawa, so idli cooker, and she gets a idli. Tell her, wow, what a beautiful, what you have made, ma'am, amma, you have made a half spear. Like you have made 4 half spears. Then tell your friend, tell your friend or mom, you are not at all actually, you don't have love with me. You are not actually giving me a cake, a big cake. Give me an additional cake. So double-decker cake you can actually give, and try to cut these cakes like that also. Put a gems on top of it and try to understand. Take these pizzas out and find out how many triangles which you can find it out. So by doing all these things, you can actually enhance your quality, enhance you actually becoming a great architect. Addition and subtraction and intersection of the solids. Whenever you actually do lots of subtractions, intersections and additions, you get wonderful objects. It's always, I always tell people that, whenever you actually take a clay, or like you just punch somebody's face, just punch somebody's face very strongly, then they will get a bulge. Okay, now beautiful addition you have done. Okay, so you all keep on doing that. Don't punch here. Raja sir said in the morning, punch and make a big spear in his head. Don't do it, huh? Okay, this is what you have to actually do. Addition, subtraction, and intersection of solids. You practice this. Don't practice on anybody's nose or anywhere. Like this is what you have to do. Intersection, you just keep on actually doing those additions, subtractions, and intersections. They'll make you more happier, and more combination of solids will actually start happening. And addition and subtraction and intersection, identify how many additions, subtraction, and intersections are there. You have to go home, like take this picture and try to identify. This is an isometric which is drawn by one of the NATA students of mine. Try to actually analyze how many additions have actually happened, how many intersections have actually happened, how many subtractions have actually happened to create this wonderful isometric view. She had also made some mistakes, but this is how the students actually make. Okay, just take it very easy. Okay, this is the NATA question number 1. The question will be based on the solids. The questions will be based on solid shading and additions, intersection, isometrics, and all that. So a metal lunchbox, a glass water bottle, 2 spoons, and a cap are kept on a table as preparation for a trip. Arrange these subjects to form a 3-dimensional composition and draw it showing shades and shadowing. Now, there is one more combination which is coming to your life. Okay, that combination is isometric, orthographic, and oblique projections. And you have to actually use them wisely whenever you go for the composition. Okay, then you are getting this addition, subtraction, and intersections also in your because there is a spoon which is inserted there, and there is a cap on top, there is one spear. So all these things are actually getting an addition for you. You can understand that and make it. Say, all of you please understand, a spoon is not a spoon. Yeah, bottle is not a bottle. Try to understand, bottle is a cylinder. Try to tell people bottle is a cylinder. You imagine how I can actually make a bottle. I am not actually a good artist at all. Please, I even won't be. No. You are not making an artistical bottle. You are just making a cylinder. So tell them that it is just a cylinder. Make a cylinder and make it as a, they are expecting a cylinder only from you. They are not expecting a beautiful thing to happen, but they make sure that the shading is actually done. Once you make the cylinder, another cylinder on top, a small cylinder on top. That's it. One bottle is actually made. So easily you can do it. Second question, exercise number 2. This make the isometric view and project it in the parallel lines. Orthographic projection. Identify all the views. First of all, you identify the edges project the edges, try to visualize the additions and subtractions and intersections in this, mark the surfaces and do it. I've given the answer for this here. The student has projected all these things and made the plans and elevation and the front elevation. So this is the isometric which is already given. You can see here there is a beautiful cylinder which is got cut here. Okay, there is a beautiful cylinder which got cut here. There's a beautiful cylinder which got cut here. There is an addition of a prism with a cuboid. So try to understand everything and try to actually make it. This is the NATA questions which they asked. These are the NATA questions which they already asked. So they actually do this, angular one. Try to actually understand the angular ones properly and try to answer them. These are the answers which I have given you. So you can keep this and practice it at home and answer it. See, there will be lots of questions which will be asked from isometric. There will be lots of questions will be asked from the surface development. See, don't actually, practice what your some NATA tutors are actually saying, like, you have to do that, don't do it. Do it always right way. As our dean sir always says, do it always in a right way. Life is always about right ways only. I have seen one of the people actually, talking about how to, what is the president's name? APJ Abdul Kalam. I have seen one of the EPSC places.
Hello.
This, then you will actually remember Abdul Kalam. Actually remember him in a proper way altogether. Can you hear me?
Yeah, better.
Yes. Right. Next. Thank you so much. The thought of the day is architect B.V. Doshi. I have worked with Doshi in Sangat and I was there for 6 months. He's one of the wonderful persons. It's a wonderful place to work with. He's a man who actually really, the person who actually worked with Louis Kahn and a person who actually recreated history in architecture of India. He's a contemporary architect. One of the interviews he has given latest, I have actually posted that in the group also. One of the mentors for me, whenever we actually get time, sometimes I meet him in Ahmedabad. I was so privileged to be there in Ahmedabad and meet this wonderful Jain and a legend. This is Pritzker Award, the way actually Nobel Prize is given for the peace awards and all that. This is for the architects. So the Pritzker Award, architect B.V. Doshi is a great Indian architect to win Pritzker Award in 2018. Aptitude, they will be asking this question. Surely they will be asking this question. Write it. Pritzker Award 2018 is won by B.V. Doshi. Thank you so much for this wonderful moment. Thank you so much. Practice your exercises. See you in the evening.
Thank you, Raja sir, the Shah Rukh Khan of our session. You got us very hungry with all those wonderful cake pictures and pizza. I now call upon our young and dynamic professor of SRMIST SAID, Professor Raja Mutaya. He has a good exposure in the field of architecture. He has specialized in building information and modeling and worked in Singapore for a brief period before joining again as a faculty at SRMIST. Raja Mutaya, sir, please.
Thank you, ma'am. Thank you for the warm reception. Good morning, students. Hope you are doing NATA training. So I wish you all the best to join your dream. Actually, I am an alumni of SRM. I did my BArch in the year 1998, passed out. And from there onwards, I am working on architecture. I have been to Singapore for a brief period where I worked on signage industry, which was very productive. And all through these years, SRM is consistently having a very good track record of having good professors, teaching the students, and you can see the state-of-art facilities which the SRM University has. In 1993, it was an engineering college, and through the years, it has progressed to a full-fledged university with all the other departments in collaboration. Now we have a very good research department also. We have a good postgraduate course also being done. Once you complete your undergraduate, you can take up postgraduate also in the university. We have a semester abroad program also, where you can join a foreign university. We have almost 150 universities signed with MOU. So you can join any one of the university and go for a short-term course and come back and complete your degree here in SRM. So you have a wide range of opportunities in front of you. Thank you. Yeah, thank you. Thank you.
Thank you, Rajamataya, sir. I now call upon another young and very, very dynamic professor, Anup Mehme. He did his BR from SRM2. He's also an alumni from the 2000 to 2005 batch. He did his MA Urban Design from Newcastle University. He's a principal architect of AM Architecture and many other feathers under his cap. Welcome, Anup, sir.
Thank you, ma'am. Thank you for a warm introduction. Good morning, all future architects. I'm a proud, very proud alumni of SRM. I passed out in 2005. And from the time I studied till date, SRM has always been the #1 institution in architecture. And Raja Muthiah sir has given all the feathers which SRM has, and I'm pretty sure you all are aware of what is SRM. But I want to talk about a very small but yet important aspect of SRM. I would proudly say that we have one of the best libraries in all of the architecture schools that I've been to. Our library is enriched with so many books, which is unbelievable. I say this because I am from an era where internet came in only after I finished my architecture. So our case studies, our book studies, our net studies, I'm pretty sure all of the other tutors and moderators here agree with me. We never had the opportunity of information available, in our hands through our mobile. That was compensated by SRM, and we had several other students from other colleges coming into SRM, writing letter to the then HODs requesting permission to access libraries, because we also have a great repertoire of thesis, because our batch started from 92. Raja Muthiah sir is one of the super seniors of this college. And I'm proud to be associated with people like Raja Muthiah sir, professors like Raja Muthiah sir. And we have a very dynamic set of faculty. All are present here. Moderator, Arvind sir. Moderator is Anita ma'am, by the way. You always see her by the name Moderator 1. Her name is Anita Mastrianis. Ma'am, I'm giving you a welcome. And there are a lot of surprises in SRM. Which is unbelievable. First, the campus it'll just blow your mind. The surrounding aspects. So yesterday I had a parent asking, so what about the canteen, for example? I said, what canteen? There are canteens. It's like a food court here. There is no single canteen. Every day when I come to SRM, I am spoiled for choice. I don't know where to eat. We spend half an hour among faculties discussing, okay, where do we eat now? Oh my God, okay, we had this yesterday, we had that. Okay, now what to do? We are so confused and spoiled for choices. That is SRM. You'll be confused and spoiled for choices. The onus of making choice is on you. And now the onus of making choice of joining SRM is on you. And that choice is simply by cracking NATA, the SRM interview, and the SRM MCQ entrance tests. Thank you.
Thank you so much, Anup sir. By the way, he is also the host who is coordinating all the entire back show of this session is being completely controlled by Anup and Arvind sir. Thank you so much, Anup.
Thank you.
So we are on dot again. Thank you for all your attendance and your attentivity and your participation. We shall meet again sharp at 6 o'clock. Let's keep submitting your work. We will keep reviewing it, and let's come back and meet with the same enthusiasm, 6 o'clock today evening. Thank you.
Thank you so much. Bye.